less than pop data end equals 756 data start equals 78 greater than. So, have you heard about the strange seismic signals that literally shook the Earth last year? If not, buckle up. This is one of the most fascinating geophysical events we've witnessed in recent history. Back in September 2023, seismic sensors around the globe picked up an odd and persistent signal, one that kept pulsing at a very low frequency, specifically 10.88 millihertz. It lasted an astonishing 9 days. And if that wasn't strange enough, the same signal reappeared in mid-October, though a bit weaker and shorter this time. Scientists have now tied this seismic mystery to not just one, but two massive landslide-triggered tsunamis in Greenland's remote Dixon Fjord. Less than PEP data end equals 1210 data start equals 758 greater than. These weren't your typical tsunamis. What followed was even more unusual. A phenomenon called a less than strong data end equals 864 data start equals 854 greater than Seiche, less than, strong, greater than. Basically, a massive standing wave that can form in enclosed or semi-enclosed bodies of water like lakes or fjords. Think of it like water sloshing back and forth in a bathtub after something big drops in. Except in this case, the bathtub was a massive Arctic fjord, and the drop was a landslide big enough to trigger global seismic tremors. Less than P data end equals 1708 data start equals 1212 greater than. Now, Seiches are known to happen, but what makes this one extraordinary is its sheer scale and duration. Typically, Seiches last under an hour and impact areas within a few dozen kilometers. But this one sent tremors detectable across continents and endured for days. Until now, the evidence had been mostly theoretical, just models and seismic interpretations. But thanks to NASA's Surface Water and Ocean Topography, that is, satellite mission, we finally have direct observations of what happened. Less than POTA end equals 2119, data start equals 1710, greater than. The SWOT satellite captured ultra-detailed surface elevation data of the Dixon Fjord shortly after both tsunamis. That data, combined with seismic readings from a station over 1,300 kilometers away, allowed researchers to cross-validate the presence and amplitude of the Seiche. Using Bayesian machine learning models, they estimated the initial wave height to be about 7.9 meters, an enormous slosh by any standard. Less than P data end equals 2404 data start equals 2121 greater than. And here's the kicker. Both seismic waves and sea surface data aligned perfectly. Whenever the fjord's water tilted in one direction, the seismic ground motion reflected that same shift. In other words, the Earth was reacting to water swaying back and forth in a remote Arctic fjord. Less than P data end equals 2824 data start equals 2406 greater than. This event is more than a curiosity. It's a wake-up call. As climate change accelerates the melting of glaciers and destabilizes landscapes, these types of landslides and associated mega-tsunamis might become more common. The study also highlights how valuable satellite missions like SWOT are, not just for weather and ocean tracking, but for detecting rare and extreme events we otherwise wouldn't even know happened. Less than EAP data end equals 2997 data is last node equals data is only node equals data start equals 2826 greater than. So the next time the Earth hums with an eerie, low-frequency vibration, we might just be witnessing another dramatic, invisible dance of water in a far-off, frozen fjord. Stay subscribed for more videos.